we? What are we doing? So it's awesome that you guys are both joining us from out west at the mothership in Redmond. I know you're both attending the boot camp that's being held up there. Definitely wish I could have been there in person. That would have been cool to kind of bring all three of us together. But alas, we have to rely on the virtual tubes of the interweb to connect. So. Oh, okay, good.
So I know today, PJ, you've got some stuff to talk to us about, really centered around data and some of the problems customers have with data. Over time, I think I read some statistics about data implosion at many customers. That storage has become largely commoditized and very inexpensive. So customers are hanging on to more and more stuff, and they need to be able to make informed decisions on that stuff to be able to drive their business. And also maybe you need to move that stuff around, from one data source to another, or maybe from on-premises to the cloud. And I understand you've worked with some customers to help address some of those problems. So excited to hear about some of the stuff you want to talk about today.
Yep, absolutely. So as data, like you alluded to, the data explosion that we're having, this propensity of data that's coming in, being able to aggregate this data, being able to crunch this data is becoming a problem for most of the customers, right? So infrastructure on premises today, they're running into capacity issues. They're running into storage issues as well, because data is key to a business, right? So they don't want to lose any of that data. So keeping data around for long periods of time to basically do analysis is a common theme that we're seeing. But storage on premises is expensive. So being able to take that data, put it into the cloud, use the elasticity of the cloud to basically spin up compute when you need to crunch your data, and then spin it back down, store that computed data into another data store that you can basically analyze at a later point in time, is kind of what I'm going to be showing you, and some of the common customer problems that I've seen, our customers face in the past.
Okay, no, sounds like a great topic. I know, Matthew, you came from a healthcare provider, and you mentioned storage on premises is not inexpensive when you start talking about databases and being able to do analysis of that data. You're talking about solid state storage and very expensive SANs.
Yep.
Exactly. One of the things we had where I came from was, performance storage for database queries was always a problem, right? So we were always going after the next big, vendor, right? And I won't name them, but there were some really big initials out there that were selling us in millions of dollars of performance storage for these types of things. So I think this is something that we really have a value prop for these customers, to just show them how to take away that investment off of the infrastructure and put it back into the data science itself. So I think this is going to be a great topic.
Yep, absolutely. And I've been in the data, space for about 12 years or so.
You don't look it. You look pretty good for a good data guy.
Yeah. So you started when you were like, 15?
Yeah, apparently, right? It's like, if I said that, I'd be like, you're 45 now?
No.
Yeah.
I used to be a DBA way back in the day, and the systems that we would always want the fastest disk. We would always want the biggest and baddest box that we can buy out there, because we just don't know what people are going to be using. So we're going to build for peak capacity.
Yep.
And it doesn't matter. I had this one system. I used to run an e-commerce site, and if the CPU on that machine crossed 3%, I'll freak out.
Well, and then on the other side, the business puts so much pressure back on us to return the value for what we've invested in, right?
Right.
And if you don't do that, then guess what happens? Well, we're not going to buy the next investment. That was always our other problem is, these huge database systems cost us millions of dollars if we haven't returned X-fold in intelligence, right? And good intelligence too, right? So you had a lot of challenges. So cool. I'm looking forward.
Yeah, excited to hear what some of our customers are doing to try to address some of those problems and what you've done to help them.
All right, awesome. All right, so basically kind of what the title I chose was building an elastically scalable data warehouse on Azure. And, just to kind of go through some of the common problems that I've seen customers have. And this is, I'm sure many, many customers are going to have the same type of situation where there's a bunch of different data silos. Everybody likes their portion of the data. They basically carve that out, and they want to keep that within themselves, right? And they don't want to share the data across, even within the same organization. It could be from acquisition of other companies.
Mm-hmm.
But there's all of these different data silos. So when they go to start looking at what is my central 360 view of the customer, which system do I go to?
Mm-hmm.
Do I go to the marketing system? Do I go to the IT system? Do I go to the system from a recently acquired company? It's all of these different data silos that we have. So like one of the customers that I had, they're like, okay, help me bring and break down all of these different data silos and bring all of this data together, centralize the data, and have one central repository that I can start querying from.
So I see that a lot too, where I come from, and then seeing other customers is typically because everybody has authored their perspective of the data,
Yep.
and it's clean, and they want to protect that investment of cleaning that data and hygiene that they put into it, right?
Yep.
So how do you help the customer kind of go through and breaking down those sides a little bit, if you will? Help me understand is like, what's the magic words to say please, and can I have that, right?
Right. So I think some of that is a little bit of a battle as well in terms of getting, and sometimes I've seen us going in there and talking with the customers is helping to break down that barrier as well, and basically be that bridge between these different organizations and kind of show them the value of, if I have one central view of the data, and maybe in your system you might have, for example, if it was they had a call center business, they might have call center information that's valuable to other parts of the business. And if you have to bring this together, you have a much better view of that customer from the different lines of business or the different touch points that you might have interacting with that customer. So there's a lot of value to bringing all these different pieces of data together.
And in that picture you show, what I see often in our ETL processes, extend, transform, and load processes that have to run every night or periodically to populate each one of those siloed systems. So not only do you have separate environments to manage and separate storage environments, separate server infrastructure, but now you've got custom jobs that have to be monitored and changed if the data schema changes, and so that this has other problems that and challenges just from the data silos themselves.
And what I should have said is this is kind of like the business problem I see people face.
Yep.
On the IT side, there's a different problem. So basically, which system am I going to go look at? So from the business guys, they're like, which system do I go look at, in order to find my view of that customer's information? But then from an IT side, they have a different problem, right?
That's so true.
You have this one machine that's doing all of this heavy lifting, or there's one or two machines, and then I keep piling on more and more data into it, and then eventually it's going to topple over. Meaning either the runtimes are going to exceed kind of my SLAs to kind of crunch this data together. And then the other problem that we have, and then we're talking about this a little bit earlier, is, data is valuable to organizations.
That's my office. How'd you get a picture of my office?
That's my office. We must share the same office. But data is valuable. Nobody wants to get rid of data, right? And I think I don't know if there's a term out there, but I would say there's data hoarders. Because it's valuable information, right? Nobody wants to lose potentially what maybe sometime later, maybe an auditor is going to come and be like, hey, I need to see that information from 5 years ago. Or maybe there's information that you want to see trends over longer periods of time. You guys did a really fantastic job with Laura talking about the data science. And in order to train a really good model, you need not small amounts of data. You need large and historical views of data in order to get a good model out there. So from an IT side, compute storage is becoming a problem. Being able to crunch over all of this data in a timely fashion, being able to tier your storage. Okay, so data is important to you. Do I want to put all of that data on my expensive SAN on premises?
Right.
Or are there other alternatives in the cloud where I can kind of have a tiered storage architecture where I can have some storage basically having more of the colder data, some storage having more of the warmer data, and then some storage having the really fast, super responsive data.
And being able to manage through that, right?
And
because
being able to.
What happens, I want to bring it up from cold to hot. Sometimes that transition time can be very lengthy, right? And I think that's another advantage we in Azure have.
Right.
Is coming out of these different tiers very, efficiently and quickly, so that you're not waiting days or weeks or ice moving through large bodies of water. Isn't that, Ryan?
Huh.
Oh, yeah.
Absolutely. So I have a really interesting quote, and hopefully you guys know what this might be. But I don't know if anybody knows where this quote from is. Forgiveness is divine, but never pay full price for a late pizza.
That's true. I agree. 100%.
Any idea where that quote came from?
Is it some type of a reptilian class, I believe?
Exactly. So that was basically Michelangelo from the Teenage Mutant Ninja Turtles. And the relevance to this slide is, I'm sure you guys probably remember that Domino's I guess, promotion that they
Yeah.
Yeah.
Exactly. So, I mean, people were kind of gaming the system, right? Because they knew that certain routes, no way the guy was going to be able to deliver that pizza within 30 minutes and they'll be able to get a free pizza.
Right.
So if you have to think about that, if Domino's was able to basically back then in the 80s, take all of this data, take all of the routes and paths that people can take, they'd be able to better figure out whether or not this is a viable business model that they can use or not.
Yeah.
So this is, just funny situation I wanted to bring up. But I was like,
that's a good point. I like that. I'm hungry all of a sudden.
There we go. So more from a techie perspective, I have data that's on the left-hand side from all of these different systems. It could be line of business applications, it could be CRM systems, and what we're seeing more and more now is basically being able to take social media information and integrate that. So I have on the very left all of this data generation, and on the far right side here, I have basically my analytics, right? How do I get my pretty visuals and be able to get information out of that data? What goes in the middle of this? So the whole point of this session is basically to kind of go through and fill in within this middle area here, what is the components that we can use and leverage within Azure to basically build a scalable, elastic data warehouse.
Okay.
So basically, we need to be able to bring in this data from all of these different line of business applications. So one of the capabilities we have within Azure is called Data Factory.
Okay. Yep.
And basically, this is data movement as a service. I can pick up data from one point and I can plop it down into another area. So the first problem that we need to solve in building out an elastic scalable data warehouse is basically how am I going to bring my data to Azure?
So does this kind of help solving too a little bit of the data gravity question? It's like where the data lives is where we build everything else around it, right? Oh, I stole something from you.
No,
you didn't. And I also want to highlight that what I've seen customers make use of that particular ingest capability is to replace a lot of custom jobs, and so when that can't be understated to the degree of benefit that brings to a customer to eliminate a lot of custom goo that they have to maintain and replace it with something that's commercially supported that scales on demand. If maybe today you've got terabytes of data and tomorrow you've only got couple hundred megabytes of data you need to import, that environment can scale accordingly to be able to pull that information in.
Absolutely, and the beauty of this is basically this is data movement as a service, right?
Right, exactly.
I like that. I'm going to steal it just so you know.
Well, I heard that from another small guy.
Did you?
Yeah.
Brilliant.
Yeah. I shouldn't say I stole it.
You borrowed.
I borrowed.
We borrowed. We reused it. We recycled. Okay.
I mean, and Data Factory could be one of the areas that you can use, and that's native to Azure, and you pay for it when you use it, and when you're not using it, you don't pay for it. But I mean, if you have a lot of investments into third-party technologies as well.
I recognize those names.
Yeah. You can continue to reuse that within Azure. So, I mean, you don't have to use our first-party products. If you have IT knowledge and you have existing packages that you want to bring to Azure, by all means, bring those into Azure. It's a platform, right? And the above area is basically talking about how do I bring in batch information. If I wanted to do streaming information like social media or IT sites, devices, I can bring that in either with Kafka or Event Hubs. I have this capability to basically, with any one of these technologies, this is what I'm going to use to bring my data to Azure.
Gotcha.
So use the first party, use third party, don't care.
Okay.
As long as it's landing in Azure.
Gotcha.
And answer that data gravity question.
Yeah, true. There we go. I knew it was coming.
Because data is sticky.
Yes, that it is.
All right, so after I bring in this data, I need to put it somewhere, right? So we have two capabilities in Azure right now. We have Data Lake, we have Blob Storage. Data Lake has some more advanced capabilities around ACL permissions down at the individual folder levels.
Okay.
Blob Storage is a little bit cheaper. You can use any one of these to basically store your data. Think of this as like a bit bucket that I'm just going to dump my data to, right?
So to just to that point, like what have you seen, more customers using? I know you said one is less expensive, but I mean, for a typical enterprise that you've worked with, with lots of line of business data, I mean, is there an easy decision point to decide one over the other?
Is it like a if it's this much data go here, if it's this much data go there, or is it type of data, or? So
Blob Storage had some limitations. I think today it stands at 500 terabytes is kind of the upper limit. That's going to be lifted in the near future. And I would say what I have seen personally is more and more people using blob storage.
Okay.
Because it is available everywhere, right?
So there's no region dependency. That's a core Azure service available at every Azure region around the world. So,
right.
Yeah.
A lot of people see the data lake nomenclature and they're like, okay, if I'm going to build a data lake, I must use data lake.
So we may be kind of having some old ways of thinking, and when I hear the data lake terminology, because I know that term's been around for about a decade or more.
Right.
Yeah, okay.
Exactly. So you can build a data lake anywhere, right? You can build a data lake using Azure Data Lake. You can build a data lake using blob storage.
Yeah.
Really doesn't matter.
That's it's an interesting term. I'm going to recycle that with my next conversation.
So when I start bringing my data into either data lake or blob storage, for my demo, I'm going to use data lake. I need to basically do something with that data, right? I need to either cleanse it. I need to maybe be able to join data together. I need to normalize the schema. And basically, I need a compute engine that basically is going to take this data and transform it. And that's kind of part of your whole ETL process. So you can use Data Lake Analytics, which is, again, a PaaS offering where I pay for the jobs when it's running. I don't pay for it when it's sitting idle. So if I were to, for example, I've used SSIS in the past. So I could potentially spin up an SSIS machine and I can have that running, and my ETL process would be running maybe at 9 o'clock at night till 12 a.m. or whatever. And when it's not being run, if I have the VM on, it's still going to consume cycles, right? With Data Lake Analytics, I basically pay for the jobs when they're running. I only pay for that job runtime. And you'll see from when I get to the demo, it's really cheap for me to do massive amounts of transformations.
All right.
And basically, and this is kind of where this whole data lake concept kind of comes in. What I would do is when I'm bringing my data in from all of these source systems into Azure, I want to kind of structure it a little bit, right? So I'd have this landing area, and maybe like in the example I have, I'm just doing this massive ingest of a bunch of, it's New York taxi information. It's like one of the most widely known data sets out there that's really large. I was like, what's a large data set that I can use that's publicly available for the demo? It's a New York taxi data set.
Yeah, there you go.
And what I did is I basically landed all of this into a folder in its raw format. And basically I had taxi information from the yellow cabs, from the green cabs. There was some Uber information. I just dumped everything into one folder.
So we're even changing a little bit of this ETL to ELT.
Exactly.
Kind of, okay,
yep.
Cool. Yeah, gotcha.
So I extract, I load it somewhere, and then I transfer it.
All right, got it. Okay, I'm following you.
And then what I did afterwards is basically I kind of stage, you can stage the information afterwards. And maybe in my scenario, I was basically converting it into folders, right? So I would say, order it by year, by month, by day if you wanted to, depending on the granularity, and put some sort of structure in terms of how I'm storing my information. Then basically, after that, I can enrich the data by maybe I want to bring in weather information. Maybe I want to bring in information from another line of business to basically make this data set a little bit more richer. So I can have this within an enrichment area, and then I have my final product. And the beauty of this is basically, as you go through these steps today on premises, you're basically only storing the final output. So what happens to those columns that you disregarded that you thought was not important?
But come back later and figure out they are?
But come back later and figure out they are.
Yeah, okay.
So if you create this kind of data lake structure, I have the information down in that staging area. 4 years from now, or maybe 4 months from now, I might go back and look at my data. I'm like, you know what? What if I still had that column information that I dropped some time back? I can go back into the staging area and I can see that data in its kind of raw format before I kind of dropped columns that I didn't need, before I converted it, before I put it into that final state.
Gotcha.
So it gives you the structure to basically see the final data that you're going to bring into your final state, but also go back and be able to go and look at, like, let's say, even for auditing information, if somebody were to hack into your system and you were collecting web logs, you can go back. I mean, I think one of the statistics I was reading recently, it takes like about 4 months for people to figure out that there's been an attack.
Oh, yeah. Yeah, it's 260-something days, I think, is the average.
Is the average,
yeah.
Right.
That's insane.
So if I had weblog information, I might have dropped all of those IP addresses, or I might have gotten rid of that from my final state, because in my reports, I probably didn't care about that.
Yeah.
But if I have all of that information still stored up in my data lake, I can go back and I can see all of this information.
Right. So I think this leads to is I know what questions I know today to have answers to. What happens if I don't have the question for tomorrow, right?
Oh, that's beautiful.
Oh, I feel that.
And you're taking advantage of commoditized, really inexpensive storage sitting in Azure to be able to retain that for maybe longer periods of time than maybe otherwise you would have done on-prem. So.
Oh yeah, traditionally I would just try to store that on-prem storage. You know, my storage guys would shoot me and charge me out the wazoo for that kind of stuff.
Like, why do you need that?
Justify use of that data, you know. It's like, okay, fine.
Right.
Exactly. So I talked about data lake analytics as that compute engine to kind of drive, moving the data from one stage to another. But you can use any technology that you want, right? You just need a compute engine because the storage by itself is not going to do anything, right?
Oh, wow.
So if I'm bringing in unstructured data, I might want to spin up an HD Insight cluster. I might want to spin up a Databricks cluster. If I'm doing streaming information, I might want to use Stream Analytics in order to analyze that data as well.
Okay.
For the purposes of the modern data warehouse pattern, I was basically using data lake analytics, but you can use any one of the other compute technologies if you wanted to.
Okay. Great.
And then once I have that information, I want to kind of model, serve, and cache that information, right? So I can choose, SQL DW if I wanted to, and SQL DW has this capability called Polybase that can just tap into data lake or blob storage and basically massively import that data into SQL DW using this Polybase technology.
So is it more like a transform on the fly, or is that you've already established your structuring and whatnot?
Yeah, so I could do one of two things, right? I can establish my structuring out on storage and then use Polybase simply to just pull in that final data. Or if I wanted to, I can have, maybe I don't, like in a data warehouse, I have my facts and my dimension tables. Maybe I can bring everything into the staging area within SQL DW and then run a query within there to kind of create my fact and dimension table. So you can do either.
Okay.
And I would say if you're the larger volumes of data that you're dealing with, it might make sense to do that transformation out onto blob storage directly or out on data lake and then pull it into SQL DW once I have my clean and final and my pristine data.
But the point being, I can pay for that transaction when I so choose to do so.
Yep.
Right.
Exactly. And with SQL Data Warehouse, turn the knob to increase the capacity you have to be able to perform some of those operations. And it sounds like that compares or contrasts to the bottom one of SQL database where you've got more of a traditional relational store where you've got some transformation that needs to occur between the store and where you're actually servicing those requests from. Okay. Yep.
Very cool.
Yeah, and actually that's a good point, and I'm glad you brought that up because I forgot.
It's almost like I knew what you were doing.
So with SQL DW, it is basically the storage and the compute are completely decoupled from each other, right? So what I can do is during my ETL process, let's say at night, I know my jobs, and this is something that you can't really do on premises, right? Because on premises, you buy for peak capacity.
Oh, yeah.
In Azure, I know exactly.
Just show me the money.
Within SQL DW, I can say, okay, well, I know my transformation period happens between midnight and 3 a.m. During that time window, I want to spike up the compute on there. And I want to scale out my cluster. And then once that's done, I can shrink it back down and I only pay for that heavy lifting during the times when I need it.
Okay.
So thank you. I forgot about that.
Yeah.
So now with SQL DW, it's not really geared towards serving data directly into Power BI. And when I say that, basically if I have a large amount of customers or a large number of end users, SQL DW is not geared towards a high degree of concurrency. And when I say high degree of concurrency, I'm talking hundreds, if not thousands of concurrent users.
Yeah, okay.
If it's like, data science guy that's just exploring data within SQL DW, by all means, you can go Power BI.
Okay.
But if you're going to publish this out corporate-wide, what you might want to do is basically you might want to cache this data. So this way you're not hitting SQL DW directly. And analysis services or Azure analysis services can serve up as being this caching layer where I can say, okay, well, within SQL DW, I'm going to keep maybe 10 years of information. And then my most currently used information, maybe I want to put that into analysis services because analysis services is completely in memory. It's not disk-based.
Is this the transitional leap that we, as seeing data guys, say SQL reporting services? Is this that kind of analogous like transition that transformations we kind of change our mindsets, or am I making a leap too far?
I wouldn't say a leap too far.
I made a leap too far. And he just doesn't want to admit it.
I could tell.
Yeah. No,
Body language says it all.
Nice try.
No, so the reporting service has its own way that it can cache data, and you can use reporting services directly to analysis services.
Okay.
So I wouldn't say analysis services would replace reporting services, but it can enhance it definitely.
Well, see, that's a good point then, because a lot of times I get that question, and I'm not as smart as you, so I tend to kind of falter over this, right? And I go, well, I don't know. I'll go ask the guy that knows. But this is a good point where for people to help them understand is like, you know, if I've got kind of like these 3 pillars I use in my data tool sets today, right, which is I'm storing it, I then transform it, and then I want to report against it. You know, these are the products that a lot of people use. And I think this is one of those things that we get tripped up sometimes in our old way of thinking, right?
Right.
In the cloud world and of change, we now have seen things in a different light. So I just
hence the name of the show, Cloud Simplified. I mean, you look at this. You look at this diagram, and you can draw lines, you know, from each one of those four pillars. You know, data factory to data lake to data lake analytics down to SQL data warehouse and analysis. So you can kind of connect the dots on what components that you want to use. So hopefully this will help some understanding the options. So
let me simplify it even more.
Oh, that was a segue.
There's more.
Did you? That was a segue.
Yeah. So and that's the thing, right? Within Azure, there's a bunch of different options and the different choices, and depending on your scenario, you might choose one pattern over the other.
Yeah. Okay.
For this particular scenario, and this is what I'm going to demonstrate. What I'm going to do is basically simplify it down to just a couple core components, right? Mm-hmm. So I'm going to use Data Factory to basically pull my data from on-premises, land it within Data Lake. I'm going to use Data Lake Analytics to transform my data. I'm going to put that into SQL DW. And then I'm going to cache that within analysis services, and then I'm going to use Power BI to basically be my front-end reporting tools. That's going to connect up.
And go. No, I'm just kidding. No, I'm kidding.
Alrighty. So this is my simplified architecture of, building this modern, elastic, scalable data warehouse.
Now, I just want to say, in my old world where I came from, this whole line of steps would have taken us 9 months to deliver.
Yep.
And that's without actually having data to report against. It would have taken us 9 months to build this.
Yep. And what I would say, go ahead.
Yeah, I was going to say, and how long would it take you to do something like, walking into a customer with some data available for you to pull in? Like, what would it take you to set this up? Just, ballpark, if you want.
Quick POC, a couple of weeks. I mean, you can get started right now if you wanted to.
I'm out of a job.
Yeah.
Yep.
Okay.
All righty. So let me jump into the demo. So basically what I did is I took the New York taxi data set. So if you go out onto GitHub, this guy, Todd Schneider, he basically has the URLs and the scripts to basically download the New York taxi data set. But I basically kind of morphed this a little bit because what he was doing is he was pumping this data into Postgres and using some scripts within there to transform the data. I basically took this, built upon it, and basically brought it into Azure and using Data Factory and Data Lake Analytics to kind of transform the data.
Made it better.
So, and the scripts that I have on here, we can put it in the show notes, and I can share this out with you guys afterwards.
Okay.
Alrighty. So the first step was basically in terms of getting my data to Azure. How do I get my data from on-premises into Azure? And basically, there's this. We revamped Azure Data Factory. This is still in preview right now, but it's going to be shortly out of preview in the upcoming months, I guess.
So this is ADF v2.
This is ADF v2.
All right.
And have you ever looked at ADF v1?
This is a huge improvement. Yeah, this is a drastic improvement.
Yeah. There was nothing to look at.
There was nothing.
Except code.
They're going to see this right now.
Yeah,
right?
This is way more user-friendly, that's for sure.
Yeah, good. So I can learn this. All right.
That's the main point. Perfect. I mean, it is dramatically different, and there's a GUI interface. I'm not that sort of guy. I like GUIs. I like drag and drop.
So you say. Okay.
And for those with ALM, continuous integration, continuous development, this has some really powerful integration with things like VSTS. All of the templates are stored in JSON, so you can export them, import them into a production environment. So it's really friendly for being able to kind of model out something in a test environment and then deploy it.
Yes, he's the smart guy.
Yep, he's the smart guy. Alrighty. So, and all I was using Data Factory in this scenario for was to pick up my data from, I had it on this one machine here, I have all of these different CSV files sitting out in this raw data, and basically taking all of that data and pushing it into blob storage.
Oh, they're not.
Holy cow, those are huge. How big? How much data is that?
It's like 250 gigs worth of data.
Oh, okay.
Nice.
240 gigs.
All right.
Okay.
Yeah.
So you filled up your solid state drive. Okay.
Well, this is a VM running in Azure. So
Okay. Oh, got it. Okay. Yeah. Yeah. Who uses local machines anymore?
Yeah.
We have all this cloud stuff.
So after I got my data sitting up into Azure Data Lake, and I can show you kind of what that structure looks like. So within here, this is kind of that folder structure that I was talking about, right?
Okay. Yeah.
So I have my raw information, which was just this raw files, and like if I were to look at the yellow capsi tag taxi cab information, I basically kind of sorted it out by years. And if you were to look at the scripts that basically Todd provided, as they went through from year to year, the schema is completely different. Well, I shouldn't say completely different. 2009 information, for example, might have a different schema or different columns within those CSV files.
Oh, yeah.
Compared to like 2014.
So so data doesn't have to be consistent in its model. You can still transform and work with it in a very...
Absolutely.
This is typically a DBA's nightmare to deal with, traditionally. Yeah.
Remember that 9 months I was talking about? Add another year now for the data work.
Right. So just to clarify too, so this is Azure Data Lake that you're showing us, and you had that folder structure was built with automation, so you didn't go through building those individual folders for all of the data you had, right?
So I used PowerShell to basically build out my folders, and then I can show the PowerShell script as well. What I did was, once I landed it into this landing area, I basically wrote a PowerShell script to basically look at the file naming and put it into its individual folders. Because I mean, I'm a lazy guy. So.
Okay, no, I am as well. I just kind of wanted to clarify like what the steps are. So and we'll be sure to put all your scripts in our show notes.
Yep, exactly. So yeah, I just looked at files, and that's what I used to basically say, okay, well, this has 2014 in it, shove it within the 2014 folder.
Okay.
But this was just organizing the data. How do I fix the problem of, okay, well, one file has one schema with a fixed set of columns, and then another file has another set of schema structure where it has, a different set of columns within there. So I have, and I'll show what I did in a quick second here, but basically within the prepared folder is kind of where I have my normalized schema. And if I were to go through, and I won't click through every single thing within here, but if I were to look at, for example, my any one of these files within here, all of the column lengths are pretty much the same. So how did I kind of solve for that? So within Azure Data Lake, I basically have, and I'm going to look down for a quick second here. These are all my scripts that I use to basically kind of convert it. So this is using what's known as USQL, so it's kind of like SQL. If you look at the syntax, it looks just like SQL, but it has some extensions in there. And USQL is what Azure Data Lake Analytics leverages.
Okay.
And if you were to look at this script here, what I'm doing within here is I have all of the column names that the file could potentially have. And if I know that, like, for example, this is looking at the pre-2015 files. With the pre-2015 files, I don't have these columns within here. I don't have pickup location down at the file level. So I know when I connect up to that file, I'm not going to see these columns. So I'm commenting it out in here.
Oh, okay.
And then when I go to write the file, I basically have every single column that the normalized schema would have. So for the columns that is missing location ID, I'm just basically sticking it with a blank column. And what this would do is when I use Polybase now to ingest the data, all of the files look uniform. They're exact.
Perfect.
So you're using SQL Data Warehouse, Polybase, to access your data that's stored in Data Lake too. So you're using USQL with Data Lake Analytics to. Okay, got it. I just want to make sure I'm following.
To basically transform the files to have a normalized schema. So that every file looks exactly the same.
So one quick question about that, as I'm thinking about maybe from year to year or vendor to vendor, this is coming from multiple different taxi vendors. How do you handle a situation maybe where the column names are different? It might be pickup underscore location or pickup location, without an underscore as an example. Where you've got naming nuances. How do you handle that?
Yep. So exactly. So that's kind of what I'm stepping through within here.
Okay. Yep. Okay.
So if you notice on the right-hand side, I have a bunch of different script files that I have. So like, let's say, I'll pick on the yellow taxi information, for example. So previous to 2015, they had one naming standard. 2015 to 2016, the first half, they had a different schema. 2016 H2, they had a different schema. 2017, they had a different schema. So for each one of these years, basically what I'm using within NoSQL is I know what the schema of that file would look like. I read that file in, and then basically I write another SQL script that basically is pushing the data out into more of this normalized schema that basically is going to handle for all of these nuances where one file might have one name for this column header or one file might be missing this column name. I'm using NoSQL to basically dump out this normalized schema for every single one of these years into my prepared folder within Data Lake.
Okay, I got it.
And then, so this is, let me just, and I'll zoom in one second here. If I can find my zoom in. So within here, this is basically where I'm using PowerShell as the kind of that driver, right?
Oh, okay.
And within PowerShell, what I'm doing is I'm looking at the year of that file name. And depending on the year of the file name, I'm basically kicking off a different Azure Data Lake Analytic job in parallel.
Oh.
So you do this, like, this is a PowerShell script that's doing your ingest, and it's kicking off the jobs to actually process it? Is that basically what this is doing?
Yeah, so this PowerShell script is basically iterating through all of the files that I have within my raw folder, looking at the file name, and depending on the file name, kicking off a different NoSQL job to basically transform it.
Okay.
Parallel.
Got it. Okay.
Kicks this off asynchronously.
Okay.
And obviously, yep, I can share my scripts afterwards.
Yeah. Now, thinking again about the challenges we highlighted earlier, where you got schema changes or columns that were added from year to year, or that change, what would happen? Now, you've got all these NoSQL queries you've built. If along comes another piece of data that you aren't aware that maybe you're getting from some external source, or you're ingesting as part of your analytics that you've built, that has something unexpected that you haven't accounted for. Like what happens? Where does it just break?
Yeah, what happens?
So that's a great segue, because I was going to jump into the Data Lake Analytic jobs itself. Okay. So the short answer is it'll break. And so basically what would happen is, because we can only handle for what we know, right?
Yep.
If there's a different schema that's coming in that is unexpected, and this is where we can have some monitoring around the NoSQL jobs. If it encounters an error, like, let's say if it expected 10 columns and basically now all of a sudden you have 15 columns or 5 columns that you didn't account for, the NoSQL job will break. So within here, and I've been testing this out for the last week or so, and I've only been able to rack up $36.
You're a big high roller, I can tell.
I am. So
it's coming out of your paycheck. You know that, right?
Probably is. This is the deepest portion of my architecture, I guess. So you can see in here, you have monitoring capabilities around the jobs. And the reason why I wanted to show this is the yellow taxi cab data. So first of all, to answer your question, you would see this failing within here, and you can tie notifications around that.
Okay, awesome. So you can, using my Ronco food dehydrators thing that I highlighted, those infomercials, you can't just necessarily set it and forget it, but you can have it notify you when you need to take action. So
absolutely.
Okay.
The system is we haven't built Skynet yet.
Yeah, I didn't know you were a dehydrator.
Yeah, no,
I don't know. I just I didn't.
Oh, sure.
So what I wanted to also show you guys is, so the yellow taxi cab information was maybe 100 and something gigs. I can't remember exactly what the count was. But basically by using kind of this methodology that I had set up, where I had these NoSQL jobs, I had this PowerShell script that was doing this transformation, I basically went through all of these files in parallel, and the longest runtime for one of them was 13 minutes. So I converted all of these files into a standardized schema, and that, to me, when I did this, I thought that was huge, right? I converted all of this into a standardized schema within about 13 minutes or so.
So I'm supposed to have
the power of cloud. We can scale up, and those were hundreds of gigabytes of files.
Hundreds of gigs. Think about what you would do on premises today to convert that. You'll have to be in serial, right? And if you were to look at this 13-minute time, 9 minutes of that was spent in queue. So basically just waiting on resources.
What?
Oh,
I had 100 and something files. It can run 20 in parallel at a time.
Yeah.
And then the rest of the time it was just running.
Just waiting for the.
Just waiting.
So it's a FIFO system, right?
Yep.
Yeah.
Exactly.
I saw you had 526 some odd jobs, so there was some pausing that had to occur while other jobs waited for other jobs to finish. So,
exactly.
Okay.
9 million pumped out into the normalized schema in, what was that, 2 minutes? 2 minutes of actual runtime.
Yeah.
Wow.
Interesting.
All right, so I have all of this data now cleansed, transformed, sitting still in Data Lake, right? How do I bring this in now into SQL DW so I can start running some reports against it?
Yes.
So the next step is basically to use Polybase within SQL DW, and Polybase sounds like this, scary technology.
It is. It is.
It is relatively simple. It is very, 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 very simple. So
I can trust you, right?
Yes.
Okay.
The whole theme of this is cloud simplified, right?
Uh-oh. I see someone's been to replace me.
So, and I'll run a couple of these scripts here. I won't go through everything. I don't have to. So basically within my architecture, I have one control node and 10 compute nodes. That's what I use to basically bring all of this data in. And to pull in all of that information, I think it took me 15 minutes or so to pull in the entire 248 gigs worth of data.
So you have a lot of coffee time is what you're telling me.
Yeah.
That's what I thought.
Exactly.
I won't tell nobody.
So, and to set up Polybase, it's relatively simplistic, right? I need to, and by the way, this is not the real key. So
That's what I was going to say. I'm screenshotting this thing right now.
Sorry. I will look.
No. There's a lot of J's and D's. You pattern it in here.
Okay.
So basically, in order for me, how do I take my SQL data warehouse and hook this up, wire it up to my data lake? So I need to give it a credential, which is basically that identity that has access into my data lake. So once I set up my credential, I store that securely within the SQL data warehouse. I then give it the path of where my actual data lake is. This is the path of my data lake account. I'm just setting up a schema where I'm going to put the tables out to. And then I start creating all of these external tables. So these external tables is basically, so what I have on disk, or what I should say, what I have on the data lake is CSV files. I need to tell SQL DW how to translate those files.
Okay.
What is the column names and what is the data types? So this is basically applying what's known as schema on read, right? So I'm applying the schema over the files that's sitting out onto blob storage.
Okay.
And if I were to look at this, let me scroll down just a little bit more.
Still, that amazes the heck out of me, because when you think about the traditional, relational data world where you have to, and how data is actually stored physically on disk, and the relationship between that and your schema and indexes, your clustered index and so forth, to do that on the fly is pretty impressive.
Yeah.
Yep.
Schema on read. I don't think a DBA thought that would be possible.
Exactly.
Yeah.
And the beauty of this is I'm pointing it out to this root directory called yellow. So this is why I had to go through that process of standardizing the schema of these individual files.
Okay.
Because once I land this in my prepared folder into this yellow folder, I can read all of the hundreds of files that I have sitting out there all at once.
So it will enumerate those folders, those year folders. That's really just more of a organizational nuance that you applied to make it easier for you to be able to find those data files. But SQL knows how to ingest that based on you just pointing it to the location that it sits in, and you're good.
Exactly. And this is basically reflecting a schema over the data that's being stored out into data lake, right?
Okay. Yep.
In order for it to be more performant, what I would potentially want to do, or what I would want to do, is basically bring this into SQL DW.
Okay. So there's okay. I'm with you.
So now what I'm going to do, and here's the timing that I basically had within here. So after I have said, okay, this is where the data sits out into the data lake, I'm going to run what's known as a create table as select. And this is going to bring the data and store it in a columnar fashion, which is heavily compressed, and basically bring this into SQL DW itself. So 214 gigs took me 15 minutes at the DW 1000, running at about 233 megabytes per second. And DW 1000 is basically 10 nodes. That's fast.
It's like building a race car, man. It's like quick.
Yeah,
well, I mean,
you can go higher than this.
Well, one thing, using a race car analogy, in all seriousness, and we had these parallel data warehouses that were really expensive, packaged clusters of servers that customers could purchase, and we're giving customers access to that sort of horsepower, and just paying on demand and allowing them to turn it up and down. So it's from a cost standpoint, that's pretty amazing.
Right, I mean, because I was almost one of those customers. I almost bought a PDW instance because we were looking at another vendor, and one of our challenges was we needed that MPP, right? We had to have it because we were talking petabytes of data in genomics and cancer data and whatnot. And it's just like, okay, what if I buy this node? Well, what happens if I have to grow? Oh, I have to buy another node. Well, what happens if I don't need the second node all the time?
Right.
We were trying to make business decisions.
You own it. Yeah.
Fixed assets, right?
That is a key. Yep.
Yeah. All right. Sorry.
No. The thing is, we can't stress that enough, right?
Yeah.
This is highly scalable, highly elastic. You pay for what you need when you need it, not when you don't have to plan ahead.
Well, not just going big, but also shrinking it, right? So like you can come back down to this itty bitty thing. Oh, and then turn it off if you don't need it, right?
Yep. Oh.
So, and Matthew, just to quantify that, like when you were looking at that in your former career, pre-Microsoft, are you talking like 7 figures, 8 figure? I mean, was it a pretty?
Your starting point was multiple 7 figures. Easy.
Okay. Yeah. So compare that to PJ's $36 bill. So.
Yeah, I know. It's like lunch. It's like a nice sushi lunch.
Right. Okay. Yeah, that's impressive. Okay, got it.
Alrighty. So I have my data now in SQL DW. I want to start doing some reports.
Mm-hmm.
So now I can wire up Power BI to this.
Mm-hmm.
So let me open up my Power BI report. And
this is so you're connecting Power BI directly to SQL Data Warehouse, which you said there's some limits on the number of concurrent users that can do that. So now this probably wouldn't be how you would expose it to the business, but this is a way that you can investigate it and do some review of it, correct?
Absolutely.
Okay.
So basically, as the person that's going to be authoring these reports, I'm not quite sure what I'm going to be looking for. I want to just basically be able to tap into this curated data that I have within SQL DW. I can basically wire this up directly to, so if I were to look at my...
So big words, as I say, it's the answer is the correct answer to the question I'm asking, right? So if I've done this, then I know, it's not crazy. It's in the realm of what I expected.
Exactly.
Right.
And I'm going to build out this report here. Mm-hmm. So this is going directly against SQL DW. Mm-hmm. And then in this case, basically, I have 2 billion rows that's sitting within SQL DW.
Is that it? Just 2 billion?
That's small data set, right? Not nothing too fancy.
All in 10 minutes was what I saw, right?
But I mean, if I start interacting with this data now, we can see it's actually not that bad because I think I cached a little bit of that. Let me go on to 15 minutes. So if I go down to 15 minutes, we can see these little wheels turning and chugging in here. Mm-hmm. And basically what's happening, and this is why I wouldn't necessarily expose this directly to my end users.
Right.
Every time I start interacting with this, it's basically generating a new query that gets sent to SQL DW.
And going against all of that data in Data Lake, because now you got that schema on read, and this is where we're applying that to actually pull data or process it. Right?
But it's insane. So I'm trying to wrap my head around the fact that in a graphical way, I'm slicing and dicing, I'm drilling down and across, and all the while it's dynamic.
Yep.
It's not like I have preloaded all the data into Power BI and I'm sorting here like what I would do with an Excel.
Right.
I've loaded all and I'm taking a pivot table and I'm waiting for ages for me. And I can't shove all that into Excel because it has a limitation. You're going against a DW stack.
I'm going directly. So Power BI has this capability to do direct query.
All right, mind blown. Just mind blown. Because it is for me.
Mind especially blown for Matthew because I know that he really likes the Excel pivot tables. You bring him into a customer.
I was a decision maker, and a lot of times when we were looking down at data to make key decisions, we'd always have to go back to the data guys and go, "I need more," or "Can you show it to me this way?"
Right.
And for me to be able to sit there and click it myself, it's mind blowing.
Right. That's pretty. It is pretty impressive. So now you've done some exploration. You realize the data is valid, looks statistically correct, and now you want to be able to expose this more widely.
Right.
Now that sounds like it comes the next and final step.
Next and final step. Yep, okay. Exactly. So basically, the next step is basically I say, okay, well, I think this is what I want to look at. I want to throw in some calculations within there. So like maybe that total trips, rather than having to go out every single time and do aggregation against that, what I can do is, and what I'm showing in here is Visual Studio, and basically using analysis services to create this data model and create some very simple calculations. I only did,
well, this is
trips.
the cube. This is the cube. You've figured it out. You're now handing it to the business in the cube that the business has asked you the questions and say, yeah, here it is.
Here it is.
Now, if you want to go play with it, fine.
Exactly.
Yeah.
And the thing is I can, and this is where it gets interesting, right? All of my calculations I can have within Azure Analysis Services. So this way the end user, they don't have to go figure out, okay, well, what's the formula to create this?
Oh.
You have this all in one central place.
Yeah.
I can do all my calculations within Azure Analysis Services. I can make things more friendly. I can say, okay, well, I want to rename these column headers.
Well, there's no guesswork, right? Like when we always had the problem when someone ran an Excel spreadsheet and ran formulas was we questioned then their math.
Yeah.
Right. But if you gave it to a simple place and it was approved, then everybody comes from the same place.
Exactly.
And everybody can trust the data.
Yep, that's a key point.
Well, mind blown.
I'm mind blown.
So how's this data refreshed? So now you've got your data and data lake, you've got SQL Data Warehouse that can pull it out, and then analysis services issuing these queries against that to effectively cache it and make it available for the business. Like, do you set up a frequency that this gets updated, or does it just?
Yeah. So I can use something like an Azure function to basically say, okay, on whatever schedule I want, go ahead and kick off this Azure function to basically refresh the data from SQL DW and cache this within my Azure Analysis Service.
Right?
Okay.
Like, new data is entering at a capacity of what, right? I mean, you can get creative. Is what
you can get creative, exactly.
Okay.
And the other thing is maybe I don't want all of my information, my 2 billion rows. What I did is I basically partitioned the data out, right? So I can say, okay, well, I only want to cache 2016 and 2015's worth of data. So I'll only cache that much because everything is going to be held in memory, right? So the more I put out there, if I don't need it, the more I'm going to be paying for that analysis services, right? Because everything is in cache.
So I have a question, PJ.
Yeah.
So in all of what you showed, how many virtual machines are involved? How many machines do you have to patch, manage, maintain, worry about security, attack surfaces that are on it?
There's none. I didn't even think about that.
What?
Yeah.
The only
cool.
I have is my VM, which I'm running this on.
Right, with the exception of this one that you're just using for showing stuff.
Yeah.
As your workstation of sorts.
Exactly.
There's zero. So I think that's pretty cool. And even what you just highlighted with updating using Azure Functions, again, it doesn't require a server. You're using compute on demand to refresh this when you need it.
Exactly. And then the last and final thing I just wanted to show you guys really quick is this is the interaction now. If I have my data cached, you can see that, as I kind of click through in here, the response time is ridiculous. I mean, everything, there's no more wheels turning. Wow. And what was interesting was if I was a taxi cab driver, I'd want to know that, for these trip times that's more than 60 minutes, that's the one that I get the most amount of tips on.
Ooh.
I just basically was trying to figure out, what's the most, what would be the tip level based upon the duration of the trips that I was going at. That was the question that I was trying to answer.
Oh, look at you, data guy.
Exactly. I can see 60 minutes, and I'm clicking through. There's no wheel spinning. Everything is cached.
Oh, that is slick.
Yeah, that's pretty cool.
So, PJ, when we leave the show here, what would you want to give the viewers here in summary, and then tell us, what would be that example that you've worked with a customer in this space? Is it retail, manufacturing, healthcare, financial? And how did you put the bow for them?
Yeah, so I think there was a couple customers that I worked with, both within retail and then also within the travel industry. And pretty much what they were trying to get at was, how do I get this 360 view of my customer? How do I bring data from all of these different data sources and then be able to take that data and put it in front of my business analysts so they can make better decisions around, who do I market to? Who are my customers that's most likely to churn? Who do I need to, kind of provide some sort of promotional advertisement to in order to get them to come use my product.
Right. It didn't take you a year to build the system. It didn't take millions of dollars to do it. You spent $36 on a 250 gig data set And in what, 2 weeks? Well, actually, this was a lot less, but you were able to wrap that and tell us that really the best trip times for a taxi, profit was what, 16 minutes?
The 60-minute mark, I started seeing more and more tips come up, probably because it's a little bit longer duration.
Yeah.
And just to be clear, the $36.
Yeah.
That was just for one component. The SQL DW and the analysis services, that had a different pricing too.
So what we're talking about, the couple $100?
Couple $100, yeah. For the duration of this running.
But still, that's you know what? To do the same thing today for a customer is a couple million.
Yes, and the thing is the whole mantra of the cloud is fail fast, retweak, try again.
Perfect. Yes, perfect. We're like talking SpaceX model versus NASA. There's different versions of cost here, right?
Exactly.
Nice.
Right. Very, very cool. Well, thank you very much. Hopefully this helped with our goal of simplifying some of the hundreds of things that are in Azure. I think you did a really good job of walking through the various different components that would be involved in a typical solution, and really provided a simplified example of what's required to implement something. So yeah, thank you very much.
Yeah, thank you, PJ.
Thank you guys for the opportunity.
Yep.